All right, students, welcome to the Analyzing Data step of the Exhibition 2020 project. We are here on Benchmark 2 ballot issues under Analyze Data. So when we're talking about data analysis, there's another term to be aware of called quantitative literacy. And the Association of American Colleges and Universities defines quantitative literacy as a habit of mind, a way of thinking about the world that relies on data and on the mathematical analysis of data to make connections and draw conclusions. So let's do a little quick warm up to see what that kind of means. So would you rather? Would you rather get paid $1 million up front for 30 days of work, or get paid 1 penny on your first day and then have your salary double every day for the 30 days? So press pause real quick, think about it, make your selection. Okay, so with some understanding of quantitative literacy and exponential models, you would have immediately chosen to get paid 1 penny on the first day with the salary doubling every day, because at the end of 30 days, you would have over $5 million. Okay, think about that. All right, so that was a fun but unrealistic example. Now let's look at some really real world math regarding exponential growth and flattening the curve. So flattening the curve, this is something that has been dominating the news. So taking a look at this, data analysis was required to understand the exponential growth of COVID-19 cases. COVID-19, the disease caused by infection of the coronavirus. So taking a look at this, we have our number of cases on our y-axis. We have time since first case on our x-axis, so this is time. And this is an exponential model of growth, of rate of spread. So with no precautionary measures, our rates of COVID-19 cases would continue to grow exponentially, which would surpass the line of our healthcare system capacities. So when we're talking about number of hospital beds, number of ventilators, equipment, that's what we're trying to prevent. We're trying to prevent a continued exponential increase that will overwhelm the healthcare system. So that is where flattening the curve comes in. So quantitative literacy was required to understand the prediction models of continued exponential growth and the potential number of cases with no interventions. So with interventions, that resulted in some big decisions by government officials to protect all of us. So this is why we're talking about social distancing. This is why we're talking about school closures. This is why we have bans on large gatherings, stores only open for essentials. These are all of the big decisions and big protective measures put in place so that we can flatten the curve. And so what evidence, you might ask, shows that flattening the curve is possible? Well, mainland China, where the start of this epidemic began. There, we can look to them for best practices because their drastic measures that they put in place that we have modeled after, they did show to successfully flatten the curve. So you can see in the beginning here, early on, this was the exponential growth. And over time, it flattened, and their battle is still not over, but it has a continued demonstration that flattening the curve is possible. So data is everywhere around us, and your ability to work with, understand, and use data is going to be an essential life skill for a multitude of types of jobs and careers, not just math or science related. Everywhere we turn, data is telling and weaving stories about our world, and quantitative literacy is what we use to make sense of that data and make decisions based on it. So what is data analysis definition-wise? It's the process of interpreting the meaning of the data we have collected and organized, and it is displayed in the form of tables, bar charts, line graphs, par charts, or multiple other representations. There's a lot of different types of charts that you are going to see. The process involves looking for patterns, similarities, differences, trends, and any other relationship, thinking about what those patterns mean, and then also thinking about where to investigate further. So these are some questions to consider when we're talking about data analysis. What story does the graph tell you? Why is the data shown in this type of graph? Who could use the data and how could they use it? So some examples would be if I chose the election issue of prison reform, this could be one piece of quantitative data that a graph that I could use. And so if I'm analyzing this graph, the story that this graph is telling me is a story about how many people are actually impacted by mass incarceration in the US. And I'm saying that because this bottom bar is the largest, but it's not actually people who are incarcerated, it's people who have an immediate family member who has ever been to prison or jail. So that is an extremely large amount, 113 million adults, when our population in the United States is around 365 million. Why is the data shown in this type of graph? This data is shown in a bar graph because it is comparing values within the same overall category. So overall category is mass incarceration, number of people impacted, and then each of these bars represent a different category of the number of people impacted by mass incarceration. Who could use this data and how could they use it? Prison reform advocates could use this data to advocate to state and local legislators for more rights and supports for all those impacted. And I'm saying that because in this part of my chart, it says most face collateral consequences even after their sentence ends, such as voting, housing, education, employment, and other restrictions. So this is showing how many people have these collateral consequences even after serving their sentence and doing their time. Analyzing survey data. So there's a couple different questions you're going to consider when you're looking at your survey results. First, what was your population sample size? That's the number of people that responded to your survey. What type of population sample did you choose, or which did you end up getting? It could be more than one. Here's a couple different population sample types. So a random sample is when everyone has an equal chance of being selected. So that could be if you had a list of all of the students that attended Rise High School and you select random names from that list of students to survey. A cluster sample is when you're choosing one specific group within a target population. So using the same example of surveying Rise High students, that would be if you selected to survey just the members of one arena at a location. That would be a cluster. Convenience sampling, that's when you are choosing people that are most convenient or most accessible to you. Now, often this is considered a biased sample and it is considered less reliable. However, it can still provide great data and sometimes it is the best we can do. So this would be if you're surveying all of your friends or surveying everyone in your household, or if you go to the store one day and survey all of the people that were present in that store. These are all different types of convenience sampling. Last would be purposeful. So this is choosing subjects because they specifically inform your study. So with the example of criminal justice reform, I would select people to survey who have had experience with the justice system because they would inform my study differently. So displaying data types of graphs. So the great thing about Google Forms, and there'll be a video following this, is that it already creates the graphs for you. So you don't have to make a lot of decisions about how to display your data. However, it's important to be aware of all of the different types of data. So you have bar charts, line graphs, pie charts, frequency tables. This is a visual representation of what these different types of graphs may look like. Important to understand the difference between bar graphs and histograms. They look very similar, but you'll notice with histograms, the bars are right next to one another, and that is because the x-axis on a histogram is continuous, meaning that it is like a number line. It is intervals on a number line. So that is why there's no spaces between these values. Histograms are often used to display measurements such as weight, height, changes over time, but the intervals are continuous like a number line. If you want to have a little bit more exposure to how to select different types of graphs, go ahead and you can click this image in the PowerPoint to watch a short video. All right, an election issue data analysis. So how are you going to submit your work for this step? One way is that you can use this graphic organizer. So if you click on the graphic organizer link, you're going to go ahead and make a copy first. So you'd go to File, Make a Copy. Okay. And it would open up this document where you can type in your name, your election issue. You've already done some quantitative research. So choose one of the graphs or images that you're going to use in your infographic, and you would copy and paste that here. So copy and paste an image that you already found. And then you're going to analyze it. What story is this graph telling you? Why is the data shown in this type of graph? Who could use this data and how could they use it? So you're only going to need to analyze one image. Then you're going to have an opportunity to input your survey evidence. So with this, in the video following, I'll show you how to copy and paste a link here. You're going to talk about your population sample size. You're going to talk about your survey population sample type. You're going to insert one of the graph images that are already generated from your Google Forms. Like I said, that's in the following video. And then you're going to analyze that one graph that you chose from your survey data. Okay. So the next video will go over how to analyze a survey. If you have any questions, please contact me or Ms. Roslyn if you are at the APCH campus, and we look forward to working with you. Take care.